So you want to get into artificial intelligence, but you look at everything out there and it just feels overwhelming, right? Well, you're definitely not alone. We're going to take that big, confusing cloud of info and turn it into a super clear, step-by-step map. Let's get your journey started.
I mean, it's the number one question, isn't it? Where do you even start? The world of AI is just so massive. Figuring out that first step, it can feel like you're standing at the edge of this huge, unmarked forest trying to find a single path. It's so easy to get lost before you even take a single step.
But hey, don't worry about that. We're here to cut right through all that noise. This is it. This is going to be your guide, your step-by-step plan. We're talking an actual, actionable path that takes you from knowing absolutely nothing all the way to building your very own projects.
All right, first things first. Every great building needs a rock-solid foundation, right? Well, AI is no different. So our first stop is all about those non-negotiable essentials, the math and the code that literally make everything else possible.
So this foundation, it really rests on three main pillars. First up, you've got mathematics. We're talking linear algebra, calculus, and statistics. And look, I know that can sound intimidating, but this isn't just for passing a test. This stuff is the actual engine running inside every single machine learning algorithm. Then you've got programming. Python is king here, no question. It's just so much easier to read than other languages, but it's still incredibly powerful. And finally, data structures. Think of things like lists and dictionaries. These are basically your toolboxes for organizing all that raw material, the data. You get a handle on these three, and you are absolutely ready for what's next.
Okay, so once you've got that theory down, it's time to assemble your toolkit. This is where we make the jump from those abstract ideas to the actual practical tools you're going to be using every single day.
And you can really think of these Python libraries as your essential power tools. You've got NumPy, which just crunches through massive calculations in the blink of an eye. Then there's Pandas. It's a lifesaver. It takes messy, jumbled up data, I'm talking like a shoebox full of receipts, and neatly organizes it into a clean table, kind of like a spreadsheet. And then you have Matplotlib and Seaborn. These are your artists. They take that clean data and turn it into beautiful charts and plots so you can actually see the story your data is trying to tell you.
But here's the crucial point for this whole section, and if you remember one thing, make it this. You can't learn to swim by just reading about it in a book, right? You have to jump in the water. It's the same here. You've got to get your hands dirty. Go to a site like Kaggle, grab a real data set, load it up, and just start playing around. That's where the real deep learning truly happens.
All right, your foundation is solid, your toolkit is ready to go. Now it's time for the main event. Let's dive into the core concepts of machine learning itself.
So at a high level, machine learning pretty much falls into two main camps. First, you've got supervised learning. The best way to think about this is like you're training a model with a cheat sheet. You give it a bunch of labeled data, this picture is a cat, this one is a dog, and it learns from those examples to make new predictions. On the other side, you have unsupervised learning. This is where it gets really interesting. You give the model a whole bunch of unlabeled data, and it has to find the hidden patterns and structures all on its own. No cheat sheet whatsoever.
Okay, so you've built a model. Awesome. But how do you know if it's actually any good? That's where evaluation comes in. You got to learn to speak the language of performance metrics, things like accuracy or precision for classification tasks, and crucially, you have to get your head around these critical balancing acts, like the constant tug-of-war between a model that's too simple, that's underfitting, and one that's way too complex and basically just memorize the training data, that's overfitting.
So once you've really mastered those basics of machine learning, you're ready to level up. It's time to venture into one of the most powerful and, frankly, exciting subfields out there, the world of deep learning.
So what exactly is a deep neural network? Well, at its core, it's a type of model that's actually inspired by the human brain. It's made up of all these interconnected layers of what we call neurons. It's these layers that allow it to learn these incredibly complex patterns from just vast amounts of data. And that's exactly why deep learning is the engine behind so many of the AI breakthroughs you hear about every day.
And the way data flows through one of these networks is surprisingly logical. It's not magic. First, data comes in through the input layer. Then, it gets processed through one or more hidden layers. And this is where all the real magic, the complex pattern recognition happens. And finally, the network spits out its answer through the output layer. It's just a simple flow from raw data to processing to a final prediction.
But here's a really important thing to understand. Not all neural networks are the same. It's all about using the right tool for the right job. For instance, you have convolutional neural networks, or CNNs for short. These are absolute masters at understanding image data. On the other hand, you have recurrent neural networks, or RNNs. These guys are specifically designed to handle sequential data, things that come in an order, like text in a sentence or a time series. The key is picking the right architecture for your specific problem.
Okay, so you've learned the theory, you know the tools. Now comes what I think is the most important part of this entire journey, actually using it. It's time to turn all that knowledge into real, tangible projects that you can actually show off and be proud of.
And listen, the key here is to start small and just build your way up. You don't have to build a world-changing AI on your first day. Nobody expects that. Start with a classic beginner project, like classifying the iris flowers dataset. Then, when you're ready, level up to an intermediate challenge, like the famous Titanic survival prediction project. And honestly, before you know it, you'll have the confidence to tackle more advanced projects, like building your very own image classifier completely from scratch.
And as you're building all this cool stuff, you need a way to organize and, more importantly, showcase your work. This is where tools like Git and GitHub are going to become your new best friends. They let you build a professional portfolio of all your work. Most of your work will happen in places like Jupyter Notebooks or Google Colab, and you'll find just endless inspiration and data sets on platforms like Kaggle.
So there you have it. We've literally covered the entire map, from the very first foundational concepts all the way to building a full-fledged portfolio. Really, the only thing left to do now is for you to take that first step and officially launch your journey.
And look, if you ever feel discouraged along the way, and you might, that's totally normal, just remember this one thing. Every single expert in this field, no matter how brilliant they seem, started in the exact same place you are right now. They were learning the basics, one concept at a time. The foundation you're building today, it's the very same one they built theirs on.
So now you have the map, a clear roadmap from beginner to builder. All the steps are laid out right in front of you. The only question left is, well, it's the most exciting one of all, isn't it? What are you going to build first?